Maybe I can zoom in. Okay.
Okay. Type 2 error, type 2 error. How am I going to describe this? Here, I went ahead and made these up just now. You're the first ones to see this. I thought, what if I just put together the steps to calculate a type 2 error probability? Let's review type 1 error, okay? A type 1 error is where you're doing an experiment, right? You're doing some research, and you reject a null hypothesis that should not have been rejected. A type 1 error is always, the probability of that happening is always whatever the significance is. Whatever the significance is, that's the probability of a type 1 error. That one's easy. You just look up the significance. Even if the problem was only giving you the confidence, you just give me the opposite of the confidence, you know the significance. But a type 2 error is when you should have rejected a null hypothesis but didn't. You should have but didn't. That's a type 2 error. And that one's harder to calculate. In this example, we're going to pretend like our sample mean was 52. And we're going to pretend like our result was somewhere in this area, because had it been way down here in the tail, we would have rejected, and it's supposed to be rejected. But let's say our sample ended up in here, and we didn't reject. We need to figure out what that probability is from here to here. But you can't just, right there in the shaded area, none of this, just in the shaded area with the true mean. You find out later what the true mean is. So let me give you an example if this were a problem on a quiz. Hey, the null and alternative hypothesis is all related to a mean of 52. But you find out later that the mean is really 50 of the population. And you didn't reject the null hypothesis, and you should have. What's the probability of making such a type 2 error? You get it? Okay, there's the description. Now here's how it's done. Step 1 is you take that sample mean and find the sample mean interval. There's the upper and lower interval. You only need to calculate one of those two intervals, whatever direction the real true mean is in. In this case, 50 is less than 52. So to calculate that interval, I only need the lower interval for whatever 52's lower interval will be, based on whatever significance is given them, blah, blah, blah. Once you have that interval, you use it then to calculate the test statistic as if now you know about 50. So it'd be the interval minus the 50, and you use that math to find the test statistic, Z or T or whatever it is. Then last, you find the p-value of that test statistic you just calculated, and that's the probability of a type 2 error. There's the 3 steps. Now let me show you how it's done. All right, here's the problem again. The sample hypothesis, the sample mean for this hypothesis, or the sample mean was 52, or the hypothesis was 52, and we did not reject it. But then we found out the real mean of the population was 50, and we should have rejected the 52. Look how far below 50 is than 52. But for some reason, we had this, our sample only ended up being, let's say right here, and we didn't reject 52. So we're trying to figure out what the probability is to making this kind of error. So we start with the 52. Since the real mean is below 52, we're going to find the lower interval. So real quick, I'm going to show it right here. The lower interval, well, hang on. I'm just going to put it right here so you can see it while I'm doing it. 52 plus and minus? No, we only have to do the minus because we only need the lower one. All right. The critical value, it gives us a significance of 5%. So we got to find the critical value equals, is this norm or is this, yeah? Norm dot S dot IMV. Is this 2 tail or 1 tail? I'm trying to remember. Do I have my notes? Is it 2 tail or 1 tail? I can't remember. It's a 1 tail, I believe. Let me look. We'll go back. Yeah, 1 tail. So I just used the confidence, which is 0.95. Someone put that in your Excel and tell me what you get for a critical value. Or is it right here? 1.645 it says. Someone confirm that. 1.645. Anybody confirm? So 1.645 times, here we go now. I have to use the standard deviation. The story says the standard deviation, population standard deviation was 6 over the square root of the sample size, which is 64. So let's go back. Right here it is. Hey, we had a sample, or we had a hypothesis of greater than equal to 52, and the alternative would be less than 52. We went ahead and did not reject that based on our sample information. We find out later that the true mean is 50, and we should have rejected it. What's the probability of making that error? Then it will also mention the population standard deviation was 6, the sample size was 64, and we used a significance of 5%. You now have enough information to find that lower interval. So we say, okay, the sample mean was 52 minus the critical value, norm S, I, and V. It's a one-tail, 5% significance is 95% confidence, 1.645 times 6 over the square root of 64. We do all this math and we find the lower interval to be 50.766. All right, we show two calculations there. We then subtract from 52, whatever that turns out to be, 50.766. Now we got to find the test statistic. We use the interval to calculate the test statistic based on the real mean. So we take, ready? 50.766 minus the real mean, which is 50, over 6 over the square root of 64. There equals our test statistic. Test stat Z. Let me review, I'll make sure you got this. We use the sample or hypothesized mean to find either the upper or lower interval based on where the actual mean is, above or below it. Since 50 was below 52, we found the lower interval. We know it's 5% significance, we use 95% confidence to find our critical value, our population standard deviation, and there's our sample size. There's our lower interval if we were to use this to find the confidence interval approach. But there's the lower interval. Now we use that lower interval to compare it to the real mean, which is 50. And we get a test statistic. What is that test statistic? 1.02. 1.02. Now we got to find the p-value of 1.02, because look at what we just did. 50.766 minus 50. We just found the p-value right there at that mark is 1.02. What's the p-value to the right of 1.022? So let's plug that in. We know what to plug it into. Here we go. Equals, is that positive or negative? It's a positive. 1 minus norm dot D-I-S-T parentheses 1.02 comma 0 comma 1 comma 1. It's a one tail. We don't multiply times 2. This ends up equaling, there it is, 0.1539. 0.1539. That is the probability of a type 2 error. Right there. The p-value of the other bell curve is the probability of a type 2 error. That's a long road to get to that. How do we feel? All right? Is that good?
That's a lot of. Wait, is this on the quiz?
Yes. I'm gonna say it again.
Can we try a different problem?
I have another problem prepared. Can we just change these numbers maybe?
Is there an equation for type 1, or is this?
No, type 1 error is whatever the significance is.
Oh.
Okay, that's type 1. This is only to calculate type 2 errors probability. Excuse me. Type 1 error is very easy to calculate. It's whatever the significance is. You never have to really do any calculating. It's the type 2 error that you got to go through this. But here are the steps. Find the sample interval using the hypothesized mean or proportion. Use the interval to calculate a test statistic. then find the p-value of that test statistic, and you found a type 2 error.
If it was two-tailed, would you have put 2.0?
I would have doubled this. I would have multiplied this times 2.
Can we find the probability of an error without knowing what the true mean is?
No, you have to know what the true mean is. If this problem's asking you for the probability of a type 2 error, I'm gonna give you the true mean. I'm gonna give you, here's the thing, I might be giving you the sample standard deviation instead of the population standard deviation. In that case, you gotta use the t equation to find the interval. You gotta use the t equation to find that critical value. You gotta use the t equation to find that proportion. So, but the process is the exact same. It's just that you gotta look to see what's being given to you, the population standard deviation or the sample standard deviation. And I'll tell you what, to make it fair, if a type 2 question is being given for you to calculate, I'll make sure it's not a proportion. So why don't we do an example of where we have a sample standard deviation instead of a population standard deviation, because the process is just the exact same except we're using the t equations.
So,
Someone had a
this
question?
one's P.
No? Christine?
No, ZZ.
That's it? All right? So here's what I'm gonna do. I'm just gonna say, we're changing this equation.
Yeah.
Let me erase this.
Because-
And we're making that the sample standard deviation instead of the population. Excuse me, I have no eraser.
No.
We're making this the sample, matter of fact, let's see, what will change here? This doesn't change at all, does it? This is the same equation, whether that's population or, oh, but the interval is gonna change. That's what's gonna change. So we have to, I need calculators. Whoever's getting this, have a calculator ready, because we're gonna have a different interval here. Let me erase this. Because we have a lot of calculating to do. This is gonna be a different equation here. This is gonna be a different equation here. All right, here we go. You ready? We're gonna pretend that this is a sample standard deviation this time. All right, we'll start at the beginning. Here we go with the interval, 52 minus, the hypothesized mean is 52, but the actual mean we find out later is 50. What's the problem? And we were supposed to reject the 52, but we didn't. What's the probability of making this type 2 error? We still are gonna use 52. 50 is below 52, so we're gonna find the lower interval. But we're also told, let me change this. We're also told our sample size is 64, our significance is 5%, but that is a sample standard deviation of 6, not population this time. Sample standard deviation. So to find our critical value, hang on, I'm gonna bring up, I didn't have those, where are those, what week was it? I put those all together. Right here, right here. Again, here is our equations to choose from. We're looking for the critical value, so we're gonna use the bottom equation, equals T, I, N, V. What goes in the parentheses here? Let me get my eraser. What goes in the parentheses is the significance. It says significance and degrees of freedom. If it's one tail though, you got double significance. Do you remember if that was a one tail or two tail? I think it was a one tail. I think it was a less than equal or greater than equal. Since it's a one tail, we have the double significance. It was a 5% significance. So this is gonna be 0.10. And I think the sample size was 64, does that sound right?
Yeah.
Oh, right here, it is 64. So degrees of freedom is gonna be 63. So we need somebody with Excel to get us an answer there.
-1.2951.
Negative one, that can't be true, is it? Let me stare at this for a second. Is it for sure?
Oh, wait.
It's 1.669.
1.669? 1.669 is, I'm gonna go 1.67 then, since the next digit's an X.
Okay, my bad, I didn't.
Is this you right though?
Yeah.
Okay, so 1.67, so this is gonna be 1.67, so you can see it's just changing it a little bit. This is sample standard deviation still 6, that's still 75. To save time here, cause we're not even getting to the new stuff at all at this point. Hang on a minute, I'm just gonna calculate it real quick. Square root of 64, we all know is 8, so I'm going 6 divided by 8, here we go. 6 divided by 8 equals 0.75. So then we multiply that times 1.67 times 1.67. Our critical value gives us 1.2525, and now we subtract it from 52. So So subtract it, I make it a negative, add it to 52. Our lower interval is 50.7475. 50.7475, it's not far off from what we had. This is gonna be 50.7475. So that's gonna change this answer just slightly. Let's see what 50.7475 minus 50, we're getting the test statistic now, we're doing the test statistic, 0.7475, so this numerator is 0.7475, and the denominator is gonna be, I think it's 0.75, 6 divided by 8, right? 6 divided by 8, 0.75, so now I'm gonna take 0.7475 divided by 0.75. 0.7475 divided by 0.75, we're gonna be below 1. This is 0.9967. 0.9967 is our new test statistic. It's less than 1. We gotta find the p-value for that, equals, here's our p-value, let me go back, oh there it is right there. D-I-S-T, D-I-S-T, drop the negative, it says. Drop the negative on the test statistic, then put degrees of freedom. There is no negative. 0.99667, comma, and degrees of freedom was 64, 63. And is it one tail or two tail? This is a one tail. All right, that one. Anybody have this already?
0.1614.
0.16
14.
14 is our p-value. Do we need to multiply times 2? Is this a two tail? No. So this is our p-value, but what it really is our type 2 error probability. There it is, a little over 16%. We did it just like we did it the other one. The only thing we did differently is we used T instead of Z because we had the sample standard deviation instead of the population, which lowered our test statistic a little bit, which, what was the previous answer? What was the previous type 2? So it increased the probability of a type 2 because we were given the sample standard deviation instead of the populations. Oh my, how do we feel? Can you calculate a type 2 error? All right, you got notes, you got a PowerPoint. What was the question? Go ahead.
Yeah, why did we calculate critical value and p-value?
As a T, because we're pretending as if this time, the second time around, that this standard deviation is a sample instead of a population.
Okay.
Because that was a sample standard deviation, we had to use T instead of Z.
Okay.
Don't forget, population standard deviation is always a Z, and sample standard deviation is always a T.
Wait.
Can you go over type 1 error, like the slides for it?
I don't have the slides open. Shoot. Let me just ask you this. What is the probability of a type 1 error in this problem? There it is. Answer is, this is too easy.
Which is that?
That's it. Boom.
Oh, really?
All right. Does that answer your question? All right. What's the probability of a type 1 error for this problem?
0.95.
No, the opposite. 0.05. Whatever the significance is the probability of type 1 error. All I gotta do is find the significance. Even if I give you the confidence, it's the opposite of the confidence. If I said 93% confidence, what's the probability of doing a type 1 error? You're gonna say 7%. Whatever the significance is the probability of a type 1 error.
No,
That's so easy.
Oh.
It's always being given to you in one form or another.
That amount is the same.
All right, so now we're getting some new stuff. Here's what I want you to do though. I want you to relax. Because I wasn't sure how far we were gonna get, so I did not put this on the quiz. But it will for sure, without a doubt, be on quiz 3. Without a doubt. This is going to the next level. So even if you don't wanna take notes, you don't have to, but don't get me wrong. I'm only gonna quickly review this on Monday of next week after the quiz and getting into the second one. Just like, you know how on week 1 or quiz 1 we had 3 main equations: population standard deviation use Z, sample standard deviation of a confidence interval use T, proportion of a confidence interval use Z, right? Now we're on quiz 2 and there are 3 main equations: population standard deviation use Z, sample standard deviation use T, proportion use Z, right? No standard deviation. Well, now we're on the third portion. We're going to the next level. And what the next level means, we went from confidence interval to one sample hypothesis testing to this is all about now two sample hypothesis testing. Let me repeat that. We're now going to two sample hypothesis testing. Look at all the different ones we're going to learn for two sample hypothesis testing. Population variances, population proportions, related means. This is a big one. A lot of people will, and a lot of you are thinking about going on to a master's degree. You're going to have to do a thesis, and this is one of the best type of approaches to use for a thesis for your master's is using related samples. I'll give you some examples. I helped a friend of mine get his master's, and he was a basketball fanatic, so he used this for basketball on his master's thesis. And then here, population means of independent samples, but we have like 3 equations in this one. So there's like 3 equations, 4 equations, 5 equations, 6 equations. But there's 3 in this one. And here's the reason why there's 3. And having independent population, independent means, because you could know each sample could be coming from a population where the population standard deviations are known, and we would use Z, just like confidence interval, just like hypothesis testing. 2 samples, as long as each of the samples are coming from, and we happen to coming from populations that we know the standard deviations, we're using Z. Here, we don't know the population standard deviations. We're going to be given the sample standard deviations for each sample, and we're using T. But here, we don't know the population standard deviations. We're going to be given the sample standard deviations for each one, and we're using T again, but there's a little catch between these two. This one, we're assuming these standard deviations are equal, and here we're assuming they're not equal. So you got this, we're assuming, even though we have the sample standard deviations, somewhere in there we'll say, but assume the population standard deviations are equal. Or here we'll say, even though we're given the sample standard deviations, this won't say anything about the population standard deviations being equal, and you've got to assume they're not equal. This is tricky, but which one to use in these two are where people get confused at this point when we get to this stage in the class. This one's obvious because you're given the population standard deviations. But these, you're going, okay, I got sample standard deviations, but which of these two do I use? So that's going to be the tough part. This is today, this is next week, and this is the week after, I think. And then the other ones are the week after, week after, week after, I think. And that will all be on quiz 3. Did I just unplug something? No. And that will be all on quiz 3. So confidence intervals were quiz 1, hypothesis testing is quiz 2, 2 sample hypothesis testing, 2 sample tests are all quiz 3. And then after quiz 3, we get into forecasting and a couple other things before we go to the final. All right, we're getting there. We're almost halfway through this class, by the way. We get through this week, and next week we're on spring break. And then after we come back, we only have like 7 more weeks of lecture and the final exam. We're going to be halfway through. So let's talk about this. Again, where am I going here? Don't forget, we're focusing on that the samples are coming from 2 independent populations, and we know the population standard deviations for each of these. All right? So here's the equation. I'm going to show you it right here. No, not that one. There it is. Here's what I want you to learn for this class. This is the one sample mean, the sample mean from the first sample minus the sample mean from the second sample. This is the population means. This will always be 0. Matter of fact, you can take this right out of the equation. For this class, this right-hand part, by the way, the same thing for this one and this one. All 3 of these have this right-hand part, but they're always going to be 0 for this class. We're not getting into the advanced. This will always be 0, and I don't even put it in the equation. I put the equation in words. I'm going to take this and show you the tricky part. Sample mean from number 1 minus sample mean number 2. There's your numerator. The only difference between this and what we've been working on is we're not using a hypothesis now. We're using an actual sample mean as the second one. Now here's the weird part. This is not the standard deviation over the sample size. This is the variance. What? The variance? How am I going to turn the information into a variance? How do I turn the standard deviation into a variance? No, you had it almost. Oh, wait, I could, no. You said square rooted, didn't you? Someone? You said square rooted.
So what's the square?
You gotta square it. because the square root of the standard deviation is the variance. No, I'm sorry, the square root of the variance is the standard deviation. So if we're given the standard deviation and we gotta get it back to the variance, we gotta square it. I think I got an example coming up, and I think the variance is 9. So what's the I think the standard deviation is 9, so what's the variance? 81, you're getting it, all right? So this is the standard deviation squared for number 1, this number 2 population standard deviation squared. You've got to turn them into variances. Each variance is divided by the sample size from the sample it comes from. So variance number 1 is divided by sample size number 1, variance number 2 is divided by sample size number 2, and you add those two together, then you square root. There's your order of operations. Numerator you take care of, denominator, variance divided by square sample size, other variance divided by its sample size, add those two numbers together, then square root. Divide your denominator and your numerator, that's how you get the test statistic. Look, we've been building and building up to this. This is what we've been coming up to. This is what this whole class has been building up to. Everything's been a building block to this. This is true research. This is how you're gonna do your master's thesis. I know all of you are going, no, count me out. I don't know. No, but as soon as you get to an employer though, they're gonna be throwing money at you. Go back and get your master's on the weekend or at night. We'll pay for it. You're gonna go free? Okay, I guess I'll go give it a try. Why not? And 90% of them have to have a thesis. Don't get me wrong, U of Flint's master's in business does not have to have a thesis. Just thought I'd throw that out there in case you're wondering. That's one benefit. I wish I would've got my master's there, I didn't though. Because I hated the thesis, it almost killed me. Mine was like 93 pages of hell. Alright, so anyway, just so you know. Does everybody see how to do this calculation? How to ignore that the mu minus the mu and just call that a 0? Alright, so you're doing it almost like the previous one. Now, what if it's a confidence interval? Here's the equation. Here's confidence interval. Alright? It's sample 1's mean minus sample 2's mean. So instead of just coming up with the sample mean here, you gotta subtract the two sample means, plus and minus critical value, which in this case is Z because we have the population standard deviations, times variance 1 over sample size 1, variance 2 over sample size 2, add those up, square root it, multiply it times your critical Z, now add and subtract it from these two being subtracted. It should look familiar to you. It's kind of the same setup as all the confidence intervals we've learned up to this point. It's just that now we have 2 samples involved instead of only 1. And we gotta subtract the two means from each other. When we get to proportions, that's what's happening here. Sample proportion 1 minus sample proportion 2 is almost the same thing. When we get there. All right, so we got the two equations. I want you to see them in action. Where am I going here? Blah, 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 blah. Slide 21. Is this it right here? Yeah, this is it. Slide 21. Here we go. No. Slide 21. No. Slide 2. No, that's not it either. Slide 2. Oh, slide 8. Slide 11. Here's our example. Is this it? No, we don't even have an example. What am I saying? This doesn't give you an example, so that's why I opened up the homework. There. By the way, here's the instructions for week 7. When's our homework due?
It's not due.
Oh man, how lucky is that? So listen, when I post, this homework's posted already. When I post the answers to this homework, don't open them up till you're done with the quiz, because there's no reason to have this homework open for the quiz. All right, just ignore it until after the quiz, because you're not handing in this assignment. Anyway, type 2 error though, I put the slides on there so you know where to find it. So make sure you mark down that chapter 9 slide, part 2, chapter 9, slides 21 through 26, are the type 2 error that I went through and showed you the calculation. All right, let's get to this homework. Make this bigger. Okay, instead of giving you a story for this first homework, I'm giving you just the numbers. It says, consider the following 2 independent sample data. Sample 1's mean is 25, sample 2's mean is 29. Let me make this bigger. Everybody see where I'm at? It says the population standard deviation for the first X1 is 9 for the first sample, Population standard deviation for the second sample is 8.5. Says the sample size for number 1 is 30, the sample size for number 2 is 36. There's all the numbers to do the setup. I mean, here we go. 25 minus 29, 9 squared, 8.5 squared. Sample size here is what, 30? This one is 35. The setup's easy. 36? Excuse me, 36. Thank you. Now I'm saying A, give the hypothesis to determine whether the population means are differ. They differ from each other. Well, that would be, here's the hypothesis. Here's how you write it when you have 2 samples. Oh, wait, I didn't open the answer? Here's how you write it if you have 2 samples. Hang on, I made it bigger. The null hypothesis. Mean 1 minus mean 2 equals 0. Remember, it said we're testing to see whether there's a difference between these 2 populations. So if there is no difference, mean 1 minus mean 2 would be 0. Now you're getting 2 independent samples from 2 different populations. So the odds of them being 0 are pretty slim. We're testing to see if the 2 samples are far enough apart, not equal to 0. They could be not equal to 0 and still be equal to 0 because the sample could have randomness in it. But if they're really far apart from each other, very far from being equal to 0, we might have evidence that these 2, that we can reject that there is a difference between them. Because the difference between them is not equal to 0. It's very far from 0 maybe. B says, construct a 95% confidence interval for the differences between the 2 populations. Before I show the answer, this would be sample 1 minus sample 2, which is, I covered it up, didn't I? 9, what is it? 25 minus, what are the 2 numbers? Yeah. There it is, 25 minus 29. The critical Z, which we haven't calculated yet, we find the critical value. Again, it's 95% confidence, so we can find the critical value, but it's Z. If we have to use significance, what would be the significance for this problem? I can't hear you. 5%, very good, because it's 95% confidence. So to set up that confidence interval would be 25 minus 29, then the critical Z, which we have to do the Excel equation to find, then here it is, 9 squared over the sample size 30 plus 8.5 squared over the sample size 36. We'd add those up, square root it, multiply it times the critical value, and we would then add and subtract it from the difference between them, which is 4. 25 minus 29 is negative 4. So let me show you, here's the math on it. The critical value, equals norm.s.inv, 0.975. Why didn't I use 95%? Because it's 2 tail, I had to use the confidence plus half the significance, so that's why it's 0.975. Equals 1.96 critical value. Then I said, okay, what's the variance for the first sample? 9 squared is 81. What's the variance for the second sample? 8.5 squared is 72.75. 25 minus 29 plus and minus 1.96 times the square root of 81 over 30 plus 72.25 over 36. Did I show any calculations? Hang on, let's take a look. I did show some calculations. But here's our interval. 0.2523 and negative 8.25. Is that right? That can't be right. Yeah, that is right. Now, how do we test if you can reject or not reject? Using the confidence interval. Same theory. Look at the null hypothesis. Does the null hypothesis number, which is what? 0, does it fit between the intervals? Does 0 fit between 0.2523 and negative 8.2523?
No.
Does 0 fit between those 2 numbers? I see 2 people saying no. Does 0 fit between those 2 numbers? One is negative, one's positive. Yes, 0 is always between a positive and negative number. Think of the number line. Negative 8.25 is way down here. Positive 0.25 is just right as 0. 0 is between them. Since 0 fits between them, we cannot reject. It's almost just like doing the hypothesis testing. You're taking the null hypothesis and testing to see if it fits in the interval, but the weird part is that the hypothesis is a 0. So you're seeing if 0 fits or not. Let's keep going. Let's see what's next. Let's see, it says, explain if you can reject or not reject based on the interval calculated. Show details calculating a test statistic. Okay, so now we're gonna do a test statistic. I'm using the, says, since 0 fits between the interval, we cannot reject. One is negative, one's positive. All right, here we go. D, here's my test statistic. Here's the setup right here. You know, 25 minus 29 over the square root of the first variance, which is 9 squared, what is that, 81 over 30 plus 8.5 squared over 36, which is 72.725. We end up getting a test statistic of negative 1.84. Just like we did with hypothesis testing, the only difference is we have 2 samples and no hypothesis. The hypothesis is 0. Negative 1.8. E says, explain if you can reject or not reject the null hypothesis based on the critical value approach. What was the critical value? We already calculated up here, 1.96. What's our test statistic? Hang on a minute, let me put it here. Here's 0, here's 1. So 1.96 is, if this is 2, here it is, right here, 1.96. Okay, so here's negative 1, here's negative 2. So right here is negative 1.96. There's our critical values. Our test statistic is negative 1.84. Negative 1.84. Here's negative 1.96. Here's positive 1.96. Is negative 1.84 between them on the inside or on the outside? Inside. Matter of fact, it's right inside, right there inside that negative 1.96, which means we cannot reject. We cannot reject, just like when we were using the confidence interval, we couldn't reject. We can't reject using critical value. Now let's keep going. That was D and E. What's F? Give the Excel equation to calculate the p-value. Explain if you can reject or not reject. So here we've got to find the p-value. We calculated the test statistic to be right there, negative 1. Oh, we're still on this. Hang on, let me keep going. And here we go. Here's the p-value. Equals norm dot dist negative 1.84366. We calculated the test statistic a little earlier. Comma 0, comma 1, comma 1. 0.0326, but this was a 2-tail, so we got to multiply that times 2, and we get 0.0652. Since 0.0652 is greater than the significance of 0.05, we cannot reject the null hypothesis. We just did all 3 approaches for a 2-sample hypothesis testing when we're being given the population standard deviation. And we just did all 3 approaches. I wanted you to see the similarities to hypothesis testing. Just little changes in the main equation. But the concept of what to do, what to look for when you're doing a confidence interval, looking to see if the hypothesis 0 fits between it, very similar to what we did for hypothesis. Getting the test statistic and seeing if it fits between or inside or outside the critical value, same as hypothesis testing. And then p-value, seeing if it's less than or greater than the significance, same as it is for hypothesis testing. There's a lot of similarities. We're just getting into some different equations, and what you're trying to recognize has been carried throughout the whole semester so far. You're trying to recognize whether it has a population standard deviation being given to you, and then you'd use Z. If you're being given the sample standard deviation, then you'd use T. If you're given no standard deviation because it's proportion, then you use Z. The same rules applied with these 2-sample hypothesis testing. It's just the equations changed a little. You realize how easy this class is? Is it just my imagination? All right, that's all I got. I will see you on Wednesday. Anybody who hasn't signed in, sign it off. Thanks.